By mid-2026, the AI market has fractured into several distinct tiers, each defined by unique performance profiles and significant price differences. In 2024, the standard architecture was simple. You pointed every user prompt, regardless of its complexity, into a single API pipe. This diagram shows that single pipe approach failing under the weight of specialized 2026 workloads, replaced by a dynamic router that directs queries across 4 distinct paths. Relying on one model for everything today creates a specific problem. You either overpay for simple tasks or watch your application fail when things get complex. The driver behind this shift is the extreme price disparity between the top-tier models and their capable alternatives. This chart plots capability against cost. Premium models in the top right are now $25 per million tokens, while the volume tiers in the bottom right handle standard production traffic for $12 or less. For CTOs, migrating away from a default provider is difficult because of the fear that a cheaper tier might break a core product feature. Picking the wrong tier carries a heavy penalty, either burning through your runway too fast or losing your competitive edge to a more capable rival. Solving this requires a look past general intelligence scores to see which specific workloads each of the top 6 models actually dominates. Mastering these distinctions transforms AI spend from an unpredictable expense into a high-yield, controllable system. We start with OpenAI's GPT 5.5, released this April. For this model, OpenAI rebuilt the architecture, pre-training corpus, and training objectives from scratch. That foundation makes it the current leader for autonomous terminal execution and complex tool orchestration. This chart shows GPT 5.5 pulling ahead with 78.7% on OS World's computer use metrics and 82.7% on Terminal Bench 2.0 for command line planning. This level of autonomous control requires paying the market's highest API prices. GPT 5.5 is a requirement for multi-step agentic pipelines, but using it for standard text generation is an expensive overkill. Anthropic's Claude Opus 4.7 reached a major milestone this April, officially surpassing OpenAI in total enterprise business adoption. This growth is tied directly to its success rate in real-world software engineering tasks. On the SWE Bench Pro evaluation, which measures GitHub issue resolution, Opus leads at 64.3%, placing it more than 5 points ahead of both GPT 5.5 and Gemini. It shares the $25 per million token price point with OpenAI, though it lacks GPT's specific focus on native OS navigation. Opus 4.7 is the definitive choice for workloads that center on generating, analyzing, or debugging code. Most production traffic doesn't require those premium tiers, and instead flows through the high-volume models. Google's Gemini 3.1 Pro is the current leader for educational and multimodal tasks. As this chart shows, Gemini remains within 2.5 points of the Frontier Intelligence Index, but it costs a fraction of the price, at $2 for input and $12 for output. xAI's Grok 4.3 serves as the primary alternative, specializing in factual accuracy and instruction following. Grok saw a major jump in agentic performance this year and remains very competitive at the $1.25 and $2.50 price points. These volume models will struggle with edge case reasoning or long horizon tasks that require unguided planning. However, Gemini and Grok provide the economic baseline needed to run AI applications at scale. Then there are open-weight models, which allow teams to bypass cloud API structures and per-token pricing entirely. Meta's Llama 4 Scout is the absolute standout here, offering a massive 10 million token context window. This enables the local analysis of massive datasets, like a decade of financial reports or entire proprietary codebases. For efficiency-focused teams, DeepSeek V4 offers a high intelligence score of 51.51 in an open-source package. This path requires a heavy upfront investment in engineering and on-premise compute hardware to replace the convenience of an API. Open source provides the necessary architecture for teams that require strict data privacy or massive context analysis. We can synthesize these profiles into a practical decision tree for any production engineering team. Looking at this flowchart, the first filter checks the query for code. If it's a programming task, the router sends it to Claude Opus 4.7. If the query requires autonomous system execution or complex tool use, the logic branches down to GPT 5.5. For tasks involving massive, private context, the router diverts the query to a local instance of Meta Llama 4. Everything else, the high-volume standard tasks, is handled by Gemini 3.1 Pro or Grok 4.3. This multi-model architecture ensures you have maximum intelligence on the hardest tasks, while keeping your overall API costs to a minimum. For CTOs, the core strategy is now clear. Use Gemini for volume and reserve Claude specifically for code. Agentic builders should use GPT 5.5 for orchestration, using Grok as a cheaper fallback for simple subtasks. Security-first teams must focus on the infrastructure required to host Llama 4 for absolute data privacy. Adopting this routing strategy increases your system's initial complexity, requiring dedicated middleware to manage. In 2026, success belongs to those who look past the individual model and engineer the smartest routing system.